Scientists have outlined their top priorities for the future of planetary science in the solar system, including sending the first-ever mission to Uranus and Neptune. But will we get there in our lifetimes? Let's dive into what they had to say. The National Academy of Sciences has just published the Planetary Science and Astrobiology Decadal Survey, which outlines the highest priority missions and research for the next 10 years. And there is good news for fans of ice giants like Uranus and Neptune. The report calls for NASA to develop a mission concept for an orbiter and probe that would explore both planets, although it also makes clear that these planets have been somewhat neglected in favor of studying Mars and Saturn. It's so exciting that the Decadal Survey has finally landed, and that our community was successful in getting the ice giants prioritized, said Dr. Amy Simon, an astrobiologist at NASA's Goddard Space Flight Center and a co-lead for the Planetary Protection Working Group on the Survey Committee. Now we can really start planning how we're going to study them. The report states that the Uranus Orbiter and Probe mission should launch no later than 2045, and that is the best-case scenario. Mars means NASA may not reach Uranus until 2053 if development stalls or if budgets struggle to support both it and the Mars sample return mission simultaneously. Then the Decadal survey says that the Uranus Orbiter and Probe can go as late as 2038. It's actually already first on the list of things to delay. In that case, there would be no Jupiter to help out, which would mean a bigger rocket and a slower 15-year direct journey, arriving in 2053. The report doesn't mention this, but it would then likely need to be launched on a super heavy lift rocket, such as NASA's Space Launch System or SpaceX's Starship, both of which are still in development. If you've been following for a while now, you probably know that we've been advocating for Uranus and Neptune for a while now too. They've been called the solar system's odd ones out, and we still don't know much about them compared to the other gas giants. We think that they are very different from each other, and also very different from the more massive Jupiter and Saturn, said Dr. Mark R. Welter, an expert in planetary rings and deputy project scientist for the New Horizons mission that flew by Pluto in 2015 and is now exploring the Kuiper Belt. The fact that they are intermediate in complexity between the more studied planets like Mars and Earth and the more simple planets like Mercury and the Moon makes them a great place to focus our efforts. And we've got some really interesting mission concepts being developed. One idea involves a probe that flies through the atmosphere of Uranus and Neptune and collects data until it reaches the surface. Another concept uses a kite-like vehicle to float above the planet's surfaces, allowing for long-duration observations without having to endure the crushing pressures and extreme cold of their atmospheres. There are many fascinating aspects of these two planets that scientists are eager to learn more about. For instance, they want to understand why Neptune has such strong winds despite being so far away from the Sun. They also want to learn more about the composition of Uranus's mysterious rings and whether or not there could be life in the subsurface oceans of its moon, Enceladus, and Neptune's S-moon Europa. But perhaps one of the most intriguing mysteries surrounding Uranus and Neptune is the question of how they formed. Scientists believe that both planets are made mostly of ice and rock. Unlike Jupiter and Saturn, which are primarily gas giants, this suggests that they formed in a different way than the more massive planets, and could provide clues about the conditions under which the solar system formed. By studying these unique planets, scientists hope to gain a better understanding of not only the formation of our own solar system, but also the conditions that led to the emergence of life on Earth. The moons of Uranus to scientists because they are thought to contain vast oceans of liquid water beneath their icy surfaces. For example, the moon Enceladus has been observed releasing water vapor and organic molecules into space through its vents, suggesting that it could have a liquid ocean similar to Earth's. Similarly, Neptune's moon Europa is thought to have a vast ocean that could contain more than twice the amount of water as all of Earth's oceans combined. The discovery of any life on these moons would be a major breakthrough in our understanding of biology and the search for extraterrestrial life, and we'll finally be able to answer the question, does it snow on Uranus? Professor Lee Fletcher of the School of Physics and Astronomy at the University of Leicester, who works on the European Space Agency (ESA's) JUICE mission to Jupiter, and is a member of the Giant Planets panel for this survey, agrees that these moons are exciting places to explore. Exploring Uranus and Neptune is going to teach us about the building blocks of planetary systems, he told me. Both planets have rings and dozens of known moons, many of which are potentially habitable with subsurface oceans. Studying them will tell us how these moons and rings formed and evolved, giving us clues about how Earth and the other rocky planets formed and evolved too. He added, ice giants make up a third of the mass of the planets in the solar system. Understanding them helps us understand the solar system as a whole, although it is not mentioned in the report. The timing of the Uranus mission could be impacted by the development of new propulsion technologies. For instance, NASA's Innovative Propulsion for Outer Planets Exploration (IPO) concept uses solar electric propulsion to shorten travel times to Uranus and Neptune significantly. If developed and tested in time, this could allow for an earlier launch window and a faster transit to the ice giants. As it stands, though the current plan is to launch a Uranus probe in the early 2030s with the goal of arriving at the planet in the 2040s. Despite the challenges involved in launching a mission to such distant planets, scientists are excited about the potential discoveries that await them. The Voyager probes that flew past Uranus and Neptune in the 1980s provided scientists with stunning images and valuable data about the planets and their rings. However, the technology available at the time limited the amount of time the probes could spend exploring the planets and their moons. Furthermore, the flybys occurred during Uranus's summer in the northern hemisphere, which meant that scientists had a limited view of the planet's winter and fall seasons. A longer duration mission, such as the proposed orbiter and probe, would provide scientists with a much more comprehensive understanding of the planets and their moons. In addition, new technologies such as advanced imaging capabilities, mass spectrometers, and atmospheric probes would allow scientists to study the planets in greater detail than ever before. The proposed mission is also timely given the recent progress that has been made in the field of planetary science. For instance, the discovery of organic molecules on Saturn's moon, Titan, and the confirmation of a subsurface ocean on Jupiter's moon, Europa, have raised new questions and renewed interest in the outer solar system. Exploring Uranus and Neptune would provide scientists with valuable insights into the origins of life and the evolution of planetary systems. However, the proposed mission faces several challenges, including funding constraints and competing priorities in the field of planetary science. The cost of launching a mission to the outer solar system is high due to the distance involved and the need for specialized equipment. Additionally, there is competition for funding from other exciting missions, such as the Europa Clipper, which is scheduled to launch in the mid-2020s, and will conduct a detailed investigation of Jupiter's moon Europa and its potential for hosting life. Despite these challenges, scientists are hopeful that the proposed mission will be approved and funded in the coming years. The potential discoveries that await them make it an exciting prospect that could revolutionize our understanding of the outer solar system and the origins of life itself. Will we reach Uranus and Neptune in our lifetimes? Let us know your thoughts in the comments below.